Um, I'll leave the stage for Colby and also hang out in comments. Over to you, Colby.
Awesome. Would you mind pulling up my slides? I don't think I can pull those up.
Yeah, here you
Awesome.
go.
There we go. Cool. Well, hey, everybody. We're going to talk about how we can optimize our media in Jamstack applications. And I'm going to try to keep my comments open for YouTube. So feel free to jump right in. I'm going to kind of treat it like a normal talk, but I'd be happy to try to answer any questions in line or at the end, whatever works best for you all. So who am I? I'm Colby Fayock. I'm the one hugging BB-8 and Kylo Ren over there. I help others get the tech out of the way to solve real problems with the web. I create educational content over on YouTube, or rather here on YouTube, and on spacejelly.dev. And I also work with the dev community as a developer experience engineer at Cloudinary. You can find me pretty much anywhere in the web by just Googling my name, as I'm the only one in the world. So we're going to take a look at a few examples of media and everyday websites where we start off with Amazon, the king of e-commerce, where they use images to showcase available products and categories. Here we have Star Cadet, where I'm a big fan of their Final Space merch. Hashtag renew Final Space. Any fans out there? Well, they take advantage of GIFs to display video-like product and category images. It's a little bit more of a creative approach, taking a typically very static medium and making it very exciting. Or NASA, exploring places that are out of this world, where we get some really cool high-resolution imagery straight from space. And sorry if you hear the banging in the background, we're getting our floor redone, so I have the door closed. Anyways, we can even see that some of this imagery is moving where they're taking different perspectives to try to give us a more interesting look at places like Mars, which is mind-blowing. But we also have stuff that is fun like Giphy, where we can share reactions with animated GIFs. Now, as you might imagine, given this talk, we're going to be focusing on the media part of these websites, or images and video. And let's not forget about our audio friend that often gets left out in the media discussions. While it's awesome to be able to enjoy some large images and GIFs on site, it does come with a cost, which is how we're going to talk about it here. And what can we do to help reduce that cost? But you might be wondering, where does media fit into my application? Everywhere, of course. It's part of the web, whether it's a simple profile avatar, an embedded video, or interactive experience. You're likely using media in some kind of way, but we're going to talk about how it fits into the Jamstack. So let's see how it fits in there. Starting off with your web app, we have some crucial components, like the page itself, which ultimately is HTML rendered in the browser that might or might not be built with a framework, like one of the Hackmamba sponsors, Gatsby. But then we need to likely bring in some kind of dynamic data. While we could use SSR, we want to deploy these pages statically to reduce overhead and improve performance. So we can make those API requests in the browser, hydrating anything personalized for our visitors. And then we have our media, which plays an important role in providing the visual context, helping people better understand what you're talking about or what you're trying to sell. But it's also a way to be creative, creating an engaging experience rather than just a bunch of text on a page. But okay, that's pretty basic. I've seen images and videos on a page before. Why should I care? This is where we come back to the cost that we talked about earlier. Let's take e-commerce, for example, which is one of my favorite types of websites to kind of work with in the web development world. If you're not familiar, conversion rate is the percentage of your traffic that actually buys something. There are a ton of studies on how website speed directly correlates to conversion rate. eBay, for instance, found a 0.5% increase in their conversion rate with a 100 millisecond load time improvement. Now, that might not sound like a lot, but eBay is worth over $10 billion. So just as an example, 0.5% of that 1 billion is 5 million. So while we might not all be billionaires, it adds up pretty quickly. That means that while all of our video and imagery might help build out a great user experience, that media is going to take up a vast majority of the size of the page. So if we don't pay attention to how we're delivering it, we're going to bloat our pages and destroy that conversion rate. So what can we do to help optimize that delivery? Well, let's start by looking at some examples of images. To start off, while JPEG is a great option, there's a lot more modern formats that we can use to help deliver high-quality images at reduced sizes. WebP and AVIF are two of those great options, and depending on the image, can bring some drastic reductions in size. We can also compress our images to the point where we're not impacting the visual quality. Maybe it won't matter for this tiny little thumbnail, but we've learned we want to display these images nice and big, right? So we want them displayed in all their beautiful glory. So letting tech automatically decide how much to optimize helps us as much as we can without noticing a visual difference. We're not over optimizing, but we're also not wasting precious KBs, kilobytes in size. If you're working with high quality imagery, your source files might be huge. If you serve them as is, the browser has to resize those images down anyway, so you're just wasting bandwidth. Resize to the sizes you need, and don't try to crunch the image just to get a smaller file size. You'll end up with a super blurry or pixelated image. Modern image delivery can give you the exact size you need on the fly, so take advantage of that. But bringing this all together, we have some pretty amazing results. Using modern formats, letting tech handle automatically optimize our images, and serving the image in the sizes that make sense for our web app, we were able to slash this particular example down from 4.3 megabytes to 51.2 kilobytes, all without sacrificing quality. So hopefully I've convinced you by now that this is pretty important, right? But how can we work with media in our Jamstack application, improving our developer experience and ultimately delivering better experiences to our visitors? This shouldn't be new to anybody, but regardless of which framework you use, except Next.js, who yells at you in your linter, you can use the HTML image tag, importantly, including a width, height, and alt, in addition to the location of the image. Not too different is the basic video tag, which has a lot more options we can get into, but ultimately you need your source and a width and a height. The more interesting thing is sourcing the images and videos. This could come from a variety of sources, like a headless CMS, or a database like Zada. Maybe all your data is pulled in together with a uniform. But ultimately, the image and the video tags you're using dynamically get their sources from this data. Where now, maybe those images and videos are wrapped in a component. This is JSX, which you might be familiar in the React world. We're passing that data right into our image and video tags. But when does this happen? What's actually connecting the dots? This is where we start to think about the framework, where we have a ton of options available to use. And it doesn't have to be a big fancy framework. We don't need to ship a huge bundle of JavaScript every time, especially if we're just dumping static data. But we start to see the higher level flow, where we have the location, we're storing the media references, we have the framework that's doing the hard work of pulling all that data into the application, then ultimately using the HTML we know and love to take that data and put it on a page. Now, this is a pretty linear solution, but it's only one of the solutions. We could alternatively build our site using local files from our project. We don't necessarily need a database to do that. But then once we deploy to Netlify, we can install the Cloudinary plugin for Netlify, which automatically will upload all those images at build time and optimize it on delivery. Or we can even orchestrate whatever external data we have, whether it's Cloudinary and Zada, or another 5 services that you love working with, pulling it all together inside a uniform and having a singular connector into the framework of our choice. But the point is, we have a lot of options for how we can pull this all together depending on our needs. So moving on from actually embedding our images and videos, we start to think about other situations where we need to work with media, such as performing work typically done on a server. And while that's fine, there's another paradigm that kind of fits really well with the Jamstack mentality called serverless. Particularly, we're going to use serverless functions, which is going to be the place where we do our media management work. You don't have to use serverless functions, but it's a really great way to build scalable APIs. So let's just briefly recap what are serverless functions. Well, you can really think of it like any kind of function that you would write in your code. You have your optional input and your output. You can also perform any kind of side effects you want as long as it fits within the environment and time limits. Ultimately, you just need to be able to perform some kind of response by firing the callback and basically declaring if it was successful or not. We have a lot of options for how we can deploy this function. Using typical cloud services like AWS, GCP, or Azure, we can deploy our functions and set up services to invoke those functions. But usually this is set up to work alongside of an endpoint, where the endpoint would actually hit this function. And usually you need to set this up manually when directly using services like AWS. But what I find more interesting, or at least an easier route, are services like Netlify and Vercel that abstract that away from actually needing people to manage all those different pieces. All you need to do is set up a function in your code and inside of a file, and they deploy the rest. We can very easily scaffold these new functions by simply creating a file in our project inside of the right directory. By default, you can add your files to an API folder. The default folder varies by platforms, but then we can use the file-based routing, which makes the function available at /API, then your file name. So in this example we have on my screen, if I have my function.js inside of my API folder, this is going to be available at mydomain.com/your provider's API route/my function. At this point, I can really do whatever I want inside the function as long as it's within the scope of those resources available. So here, I'm just simply passing back a message that says hello world. Now, I'm a big fan of Next.js, which provides serverless APIs as part of its toolset. If you're deploying to places like Netlify, you're really doing the same thing. The biggest difference is where the files are located, where in a Next.js project, it will be available in pages/API. Now, if you prefer, you could just as easily move that to a folder configured for your favorite platform, like the API folder. You would then just need to use the platform CLI or local development instead of the Next.js workflow. And how you reference the API might differ a little bit, but given that it's not fully integrated, but ultimately, either way, you're deploying a serverless function as an API to that platform. So now let's talk about how we're actually managing our media inside those serverless functions. Most serverless providers support a few different runtimes, including Node.js, Go, Python, and Ruby. But given we're in the JavaScript world here, we can stick with Node.js, where we can start to think about how we can use the Cloudinary Node SDK to perform custom actions. And just to quickly note, if you do prefer some of those other runtimes to build your APIs, Cloudinary has a few SDKs for those languages that do include Ruby, Python, and Go. But back to Node, we can start to import our Cloudinary module. We can configure our account by specifying our cloud name, where then we have full access to do whatever we want. We're simply generating a URL by passing in our public ID. But this can start to be handy when we're doing this programmatically, or more so when we need to make secure requests that require sensitive information that we don't want inside of our client. That's where using serverless functions really shine in the stack, where we can configure our API keys and our secrets for our Cloudinary account, allowing us to make signed uploads or perform any kind of action that requires authentication. Like here, I'm taking image data that was posted to this endpoint, and I'm passing it right into the Cloudinary uploader, returning the results of that upload, and essentially creating a secure proxy that I can now use within my application. As another quick aside, if you're wondering about the security around this thing, by default, the functions do not add course headers, meaning you cannot make cross-origin requests. That said, you want to make sure that your requests are only being made from an app level if they have the ability to do so, such as having an authentication layer that checks that it's an authenticated session. Now, just to visualize this a bit before we move on, we're starting off in our Next.js application, or really whatever application that supports functions, where for all intents and purposes, this is a React app once it hits the client. Inside this app, we can make client-side requests to our endpoint, which is where our serverless function comes in, where it will execute that serverless function we built, running anything we include inside. Like running our Cloudinary SDK, where we can upload, manage resources, or really do whatever we want. Once our tasks are complete, our endpoint returns a response, including an HTTP code describing whether or not it was successful, which lets our Next.js application handle that response client-side, continuing on with whatever action our visitor was performing inside the application. But now we can actually take that to another level, where utilizing Cloudinary, we can get a lot more features available to us on top of a simple upload. For instance, maybe we want to customize our upload parameters, such as self-generating a public ID if I'm using my own convention, and providing tags so that I have a sane way of finding the images I want out of thousands. You can even set custom access controls requiring usage of images to provide an authenticated token, along with a variety of analysis options to take a deeper look at your media. But we're going to look at an example of how we can utilize add-ons that extend the capabilities of Cloudinary. Here in this snippet that I'm showing, we're looking at two different examples of add-ons that we can use: removing the background of images with Cloudinary AI and auto-tagging with Google. First, using AI background removal. When uploading an image to Cloudinary with background removal enabled, Cloudinary is going to kick off a process that uses AI to intelligently remove the background. Once that's complete, you can set up a notification endpoint to trigger the next steps, or you could pull the resource until you see the completed status in the response. And while Keanu works really well as a model, This becomes more interesting in other use cases like e-commerce, where taking a single well-photographed product, we can change the backdrop in which it's presented, whether that's a simple background color to match our UI, or if we wanted to put it in an environment that's completely out of this world. We can also use the Google Auto Tagging add-on, which has a version available both for images and videos that lets us process our images using Google's Vision AI to automatically add tags to all of our images. This becomes critical when managing huge libraries of images, where it can quickly become very difficult to find specific images that you have nothing to search on. Or applying this to applications, maybe you want to give your visitors a way to search for their own media or show related media based off of what they're currently looking at. Tagging can eat up a ton of resources if you're trying to do this manually, where you can get a pretty quick win by enabling this add-on. But pulling this all together, we can provide a wide variety of capabilities and controls to customize our uploads to work exactly how we want them. So what does this look like in a real-world application? Well, if you've been to any of the dev conferences in the past couple of years, such as this one, but there's a chance that Cloudinary was sponsoring. If the event was actually in person, we typically have a booth. But we wanted to do something a bit more interesting than myself and a few of us others sitting behind a table. So we built this app called CloudyCam. While there's a million different applications that we could talk through, I built this app as a way to recreate filter-oriented photo apps like Instagram and Snapchat. The idea being that you can take a picture of yourself with the device's webcam and immediately get access to a wide variety of Cloudinary tech to customize your photos, whether you want to deal with it or pretend you're Darth Vader on what actually does appear to be a moon. While the application might seem like it would involve a lot of complicated features to make it work, really the most complicated part is local state management. Next.js, which is what I used as the portal into React application, makes dealing with the front end really easy, where you could also use Gatsby in a situation like this. But using serverless functions for proxying our media requests, we can let Cloudinary handle a lot of the heavy lifting with its wide feature set. To get started, we want to be able to snag a picture using someone's web device. So I use React Webcam, which allows us to use the native device's browser APIs inside of React. So once we snag the picture, we can set it in state, and we can show the still instead of the live feed. At this point, we have raw image data in the browser. Cloudinary really likes raw image data, so we can forward that data right along to our endpoint. In this example, anytime the image variable changes, which is what's storing that data, our useEffect hook fires an asynchronous function. Here, we're using a self-invoking asynchronous function, which then allows us to use the async await syntax, which is just a little bit of a personal preference of mine. You can absolutely just chain a then at the end of that request. But inside, we use the fetch API to post it to our endpoint. Again, passing that raw image data that's stored in state. We'll get to the endpoint here in a second, but we can see that we can then grab the JSON response. Then take those results and use React state to store that data. Which, here's a quick look at what those results actually look like from a Cloudinary upload. Primarily, in our use case, we're interested in the public ID and the secure URL. This gives us our ability to actually reference the image. But if you notice, we're setting those results as our main property. This is to allow us to both source the full image and an image that we can remove the background, having multiple options. So we're going to pull on that thread. We're going to do a very similar thing now, where this time we're waiting for our data to update. Specifically, we're waiting for our main image data to be available. And once it's available, we're going to fire a similar post request, but we're going to do that to our upload endpoint. Only this time, we're additionally passing some options that we want to, this time, remove the background like we saw earlier using Cloudinary AI, along with our original Cloudinary upload as the new source. We can simply pass the URL this time, as Cloudinary also likes taking in remote sources. Now, the tricky thing is our response object this time will give us a new image, but our background removal status will only be pending. So we have two options here. Either we can set up a notification URL by creating a new serverless function, which whenever Cloudinary is ready, it'll hit that, or we could pull the resource. In my case, I just use the polling technique from the client. This code would follow immediately after the upload we saw on the previous slide, where we take the resulting image and start to check its status by requesting the resource's details. This happens in a new serverless function specifically made to return a resource's details. With a recursive function, we keep checking again and again to see if it's still pending, but each time we're getting a response that looks similar to our upload response. But this time, we're waiting until we see a status of complete. And once it is complete, we resolve the status check and continue on with updating our local state. And at this point, we have 2 images upload. Our primary image, which is an upload from our webcam, and we have a transparent version. But now we're interested in adding some effects, the fun part. Where at this point, we can be as creative as we want. We have both the full library of default transformations Cloudinary provides, as well as being able to make up some fun ones of our own, like adding some deal with it glasses using Cloudinary face detection. Well, here I'm just using a simple gravity or the focal point. You can take this another step with the advanced facial attributes add-on. Then adding the background from the office. Or scratch that, how about the this is fine meme, where since we have the transparent image, we can just underlay the background right below it. Followed by adding myself in the frame that was on the door and friends. This one was actually a little bit tricky because not only did I need to use face detection for the glasses, I needed to detect the face for the person and then set up the crop of that so that it would be in the center of the frame. But once we have our finished piece of art, we want our visitors to share their creations. The cool thing in Next.js is that it makes it really simple. And while we could use SSR or server-side rendering, we could build this statically and use on-demand generation so that we can make a real-time request to anything that's available inside of our Cloudinary cloud and then build that page. So technically, we could probably send them to our existing public ID, maybe include the transformations as URL parameters, but that turns into one big nasty URL. But given what we just went through, we can just as easily upload our image again and then pass that public ID in the URL, making that share URL much simpler and less prone to break when getting shared. So back inside of our code, we're going to use get static props to statically compile our page. This allows us to grab the parameter and then use the Cloudinary SDK to pass back our resources right away. Now, the tricky thing here is when you use get static props, you're typically mapping out all of your paths using get static paths. Now, Next.js knows the path exists, but we just created that public ID, so we don't even know that it exists yet. But we really don't want to wait until a whole new build is ran to make that available. So instead, we're going to simply say that we don't want to pre-render any paths, and we want to say that our fallback is blocking, meaning that request will fulfill after the new page is generated. This will save us from some build time, but it will also allow us to build that new share page on the fly for our new ID. And fun fact, this will actually happen via on-demand builders using a serverless function if you're using Next.js on Netlify. Now, back to the get static props. This works by using file-based routing, where our file route is a dynamic route. We're saying here with the brackets in our file name, that public ID is going to be our parameter. When Next.js sees that in the URL, it uses it to build our page by passing it our data fetching function, where we can then upload that data. But with that, we have our image, and we can create an experience that makes it fun for people to share the results. So enough at looking at a bunch of pictures, wink. Let's give in some real code and see how we can make this kind of thing work. We're going to check out some real-world benefits of image optimization. It's pretty common for user content or media managed by non-technical people to upload full-sized images without knowing the impact at all. So we can safeguard this by automating optimization of all of our images. Here, we'll check out how we can do that with the Cloudinary Netlify plugin. So I'm going to dive right in. So let me first change this screen that I'm sharing. Oh no, William, if you can promote my screen, gonna have to do it again when I switch back to slides. Thank you. Okay. Here we go. So I created this repository called Astro Image Gallery, which it is what it sounds like. It's an Astro application that's literally just a gallery of images. Now, my goal here will be to show you how we can take these images and optimize them super easily inside of Netlify. So what I did right before this talk, you can see 35 minutes ago, I created a clone of this so that I can use this for my project. So heading over to Netlify, I'm going to go to Add New Site, and I'm going to import this from my GitHub account. So this is just authorizing me for access. And then I'm going to search for Hackmamba. You can see that that's going to pull up my new GitHub repository. So I'm going to go ahead and select that. And the nice thing is Netlify is going to detect what kind of project I actually have inside of my repository. And it's going to automatically determine the build settings, or at least it's going to try to determine the build settings. But we can see these are exactly what I need to get started. So literally all I have to do now is click deploy site. Now, if you're not familiar with Netlify or other tools like Vercel or whatever other ones, what's going to happen now is on Netlify's servers, they're going to pull down that project from my GitHub repository. It's going to build that project, and then it's going to deploy all the compiled assets, the HTML, CSS, and JavaScript from that project, and it's going to deploy it out to the web, where I will have it available at Rainbow Sprinkles. I love their little randomized names. It gets me every time. But this should be pretty quick. I think Astro builds usually pretty quickly. Let's see here. And it's actually done already. 26 seconds. That was pretty nice. But if we open this up in a new tab, we can see just like that, I just deployed a new web app in less than 30 seconds using Netlify. Now, what I want to show you about this is if I open up my network tab, specifically network tab, and I refresh the page, we can see all the images loading here, where these are just random images I grabbed from Unsplash. I just downloaded them from Unsplash, dumped them on the page. And the point is, we don't really know all the time where our images are coming from. Maybe we have an optimization workflow, but maybe we don't. A lot of times, if you have non-technical people working in your content management system, they might not know any better to have to optimize the images. So we might have real results like this, where we have a bunch of JPEGs that are big in size, and all this is going to do is bloat our page, where we can now see that that's taking up 4.5 megabytes in size. That's going to really make it hard for some people to download all these images on their page. So what can we do? Well, as you might imagine, we're going to try to see what we can do with Cloudinary. So inside, I'm going to head over to my site settings and then scroll down where I see plugins on the left. And I'm going to go to the Discover Integrations page. Now, once I'm there, we can see that Cloudinary is right at the top. But if I need to, I can also search for Cloudinary if we become unfeatured at some point. But we can see we have two integrations. We have an API integration, which is something we'll cover on another day, which makes it easier to authenticate with Cloudinary requests. But we also have the Cloudinary plugin, where I'm going to go ahead and click Add Build Plugin. Now, this is going to take me back to my site, where I can find each site that I want to add it to. And in particular, I want to add it to my Rainbow Sprinkles site. So I'm going to go ahead and click that and click install. And it's now installed on my site. Now I have two more steps. The first one, I need to add an environment variable, so it now knows what account to use for Cloudinary, but then I just need to simply redeploy it. But first, let's add that environment variable. So I'm going to head to build and deploy, then the environment section. I'm going to click edit variable names. I'm going to say Cloudinary cloud name, and then I'm going to specify my Cloudinary cloud name. And you can find that right inside of Cloudinary on your dashboard at the top left of the page. So now I'm going to head back up to site overview, and I'm going to go to production deploys and kick off a new build. And what this is going to do this time, we can watch this all unfold. The anticipation is a killer, but we'll be able to see that this time Cloudinary is going to kick in during this build process and do the work that's actually going to make it optimize on the fly. So what it's going to be doing is it's going to be taking all the on-page images in the build artifact. It's going to swap them in with Cloudinary images using automatic optimization, including modern formats and actual compression, to a point where it's not going to be visually different. So we can even see that it's loading up the plugin for Cloudinary, and this really shouldn't take too much longer. Like I said, it blows my mind how quick it is with the Astro framework, but we're done already. So I'm going to open that up in a new tab, and I'm going to still keep my other tab open. But if we start to look at this, again, the network tab, and I refresh the page, you wrote down all those file sizes, right? You memorized that already, right? But if you look at the file sizes, first of all, the type, we said they were JPEGs before, right? We're now serving AVIF, which is a more modern format. And we also, if you didn't notice, this file sizes are greatly reduced. So let's just look at what that looks like. So take beach.jpg, for instance. If we look at beach.jpg, that's 125 kilobytes. But if I go back to the other site, That was 566 kilobytes. And we did this all by adding the automatic optimization. This doesn't include things like resizing to only the size we need, because these images are likely pretty huge inside the DOM. So we can even shrink that further. But all we're doing now is just automatically optimizing to make sure that we're delivering the most modern format and compressing it to a point where it's not visually different. But we can see we went from 4.5 megabytes to 1.5 megabytes. That's a huge difference without doing any other optimizations that we could to help load these images faster. Okay, so that's enough of my demo. Let me go back to StreamYard. Okay. Willie, thank you. That was quick. Okay. So just to quickly recap what we saw how we were able to easily optimize all of our on-page images, and we saw how we were able to actually see how that impacts the page load. It was a huge difference, and where we can help deliver better experiences to our visitors. If you want to learn more about how you can work with the Cloudinary Node SDK, the docs have a lot of great examples and everything you need to get started. Or if you head over to spacejelly.dev or my YouTube channel at youtube.com/Colby Fayock and search for Cloudinary, I have a ton of use case driven examples, as well as a new repository of straight code examples using Cloudinary in projects. And there's more to come, and I'm also taking a request if you see anything that you'd like to see. And that's it. If you want to learn more chat about this talk, you can again find me anywhere at Colby Fayock. I'm happy to answer whatever questions you have, whether it's Cloudinary related or not, but we'll see what we can dig into. Thanks, everybody.
Thank you very much, Colby, for that. Yeah, that was a really interesting talk with a lot of examples and really cool website. Man, you really do like the coolest stuff. Anyways, I have a question. This one's like my first question, Colby.
Okay.
What's the quickest way to get started with Cloudinary?
So I'd say if you're on a Netlify site, that's totally the quickest way. But usually not everybody is deployed on Netlify, right? And that also kind of limits the things you can do. So we have the URL Gen SDK, which is the JavaScript client-side SDK, which is really nice for being able to easily just load up your images from Cloudinary or remotely and get it starting in that process.
That's great. That's really good. And is this the fastest way as well to derive value from Cloudinary? Because I know Cloudinary has amazing set of features. I won't lie. I use Cloudinary all the time.
Yeah. No, it's interesting because one of the most basic features we have, but I find to be one of the most compelling features, is that automatic optimization, where that's going to make a huge difference, or at least it can make a huge difference in the load time on your pages, because we're able to serve dynamically the most modern formats depending on the browser. Like that can make a huge difference in the user experience.
Yeah. Yeah, that's great. Also, is Cloudinary just for JavaScript developers? Even though this is a Jamstack hackathon?
Not at all. So languages aside, because I did show that there is a few other SDKs for whatever your favorite language is. Look at that Netlify site, right? Like all I had to do. So if you're whatever type of job you have in the development world, if all you need to do, create a Cloudinary account, grab that cloud name, and install the plugin, which you can do right through the UI, and you have your site is already going to be optimized.
That's fantastic then. I guess the participants already have like some place to start from.
Yeah, hopefully that gets started. Here. I would hope that people go beyond the plugin, but it's definitely an easy way to get that automatic optimization on a site.
Okay, that's great. Someone here has a question that says, can you please explain what upload presets are?
Sure. So upload presets are interesting, where what it's going to allow you to do is anytime you upload an image to Cloudinary, you can set a default configuration that's going to say, whenever I upload the photo, I want to do this and this and this and this. And that can include a variety of things. Now, some of the things I like to see are you can include your media analysis, where you can kick off the Google auto tagging to automatically go through your images and then tags. You can set a max width and height so that anytime an image is uploaded, if it's I don't know, 10,000 kilobytes wide, or not kilobytes, 10,000 pixels wide, you can say, I only want images to be 2,000 pixels wide, and it'll resize everyone down so you don't bloat your storage, right? And those are just two simple examples of, there's a ton of stuff that you can do with it.
That's really cool. I hope that answers your question, Aaron.
Love to see the unapologetic fangirl. Love it.
Yeah, we have a lot of fan people at Hackmamba.
And if you don't have a question now, I'm in the Discord. Feel free to @me. I'd be happy to answer any questions.
Yeah. Yeah, thank you very much, Colby. And thanks for,
welcome.
For hopping on the stream. Oh, I think there's one more question that says, what's the best way to set up a notification URL when working with features on Cloudinary that don't give immediate responses?
Sure, that's a great question. So I honestly haven't worked too much with it, but in my mind, going back to those serverless functions, what I would personally try to do is create a serverless function so that anytime, so when I pass in that notification URL, it's going to be that function, right? And then Cloudinary will hit that URL, which will then allow me to do whatever I want it is within that application.
Yep, that's great. Thanks. Yeah, one more question. I promise this is probably second to the last one. But yeah, I've seen a lot of, AI enthusiasts and engineers on Discord, on the Discord servers. So I wanted to know, what are the different, features of Cloudinary that apply to artificial intelligence and machine learning?
So I don't know quite the whole extensiveness, and I can find out more information if anybody is particularly interested. But two of my favorites are the facial attribute detection and the auto tagging. Now, auto tagging, like I was showing, is you can find, like, I love that it can pick out anything that's in the image for you or the video for you, and then you have this list of information about what's inside. So while maybe some simple use cases are being able to search on those attributes, think about the data analysis side of that, where you can go through that, and maybe you want to see, if you have 1,000 images, how many cats are in those images, right? Like, you can do things like that and actually analyze those images.
Yeah. Wow, that's really cool. So that's auto tagging.
Yep. The one that I used was Google Auto Tagging, but we also support I think is it AWS recognition, or is it Microsoft recognition? There's a tool called Recognition with a K that we support as well. We support a few of them.
Yeah, that's cool. I've tried out one, but not extensively. And Aaron has another question that goes, is there a way to upload multiple images to Cloudinary using the Node SDK? Haven't seen any online, just some, tweaking does it.
Yeah, great question. I haven't seen any ability to do that all within a single request myself. Yeah, I've seen that question asked before, and there's currently not a way to do that from a single request.
So would you take that back as like feature request?
Totally. It's definitely been asked for before. Like, I've seen it come through. But in the meantime, what I typically do for, like, say I have a list of 10 images, you can go through and loop through those and upload those. I would just usually try to self rate limit myself. So maybe add like a little timeout in between each upload so that you don't hit any kind of rate limiting, which could, severely impact what you're trying to do.
Okay, that's fine. Yeah, I think that works for now. Yeah, also to every other person listening, I think starting from today, you could start to look at the Cloudinary documentation. Colby, you could post some links on Discord so people could, start to look at maybe sample demos, and you could start trying out, ideas and start experimenting with Cloudinary and stuff before we get into the weekend and kick off the hackathon proper.
Yes. I'll post my links as soon as I'm off here.
Yeah. All right. Without further ado, I guess I haven't seen any more questions in the chat. Thank you very much, Colby.
You're quite welcome. And again, I'm in the Discord, so let me know if you need anything.
Yeah. All right. Thank you very much. Have a nice day.
Thanks, you too.